When you have a vector A, this vector is said to have a x component and a y component. Let's say this is our y-axis and this is our x-axis. From this point to this point, let's trace it down to x. Is our x component, and if we trace this to y, is our y component. Had it been this vector is displacement to be specific, if someone walk from here to here, we can say the person walk this length on x-axis and person also walk this length on y-axis. So we can calculate the x and y component for every other vectors like that. But to do that, we need to remind ourselves of this trigonometric function. When you have a right angle triangle, this is our hypotenuse. If our theta is here, this is our opposite, and this is our adjacent. You should remember this formula very well. We call it SOHCAHTOA. What this is telling us is that sine theta, which is this theta, is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite adjacent. Now let's relate this to this. This is A. We can call this AY because it is A on the y-axis, the amount of A we have on the y-axis. So opposite is AY, and this is AX. Now let's substitute all this with this. Say sine theta is equal to opposite AY over hypotenuse, which is A. Cos theta is equal to adjacent, which is AX over A, and tan theta is equal to opposite, which is AY over AX. But in vector, we mostly use this formula as AY is equal to A sine theta, AX is equal to A cos theta, and theta is equal to the arc tan of AY over AX. So I think this is very straightforward. So when you have something like this, let's call this 5. So, and you have theta here. For you to look for what the y component is or what the x component is, all we have to say is AX is equal to what our theta. Just put anything and say 5. Look for the sine of this theta, anything you put in theta, and multiply it with 5 and you have your answer. And one good thing to note is this: when you have two axes, x and y, you have to start your theta from the positive x-axis towards the positive y-axis. That is from here to here. And when you do this, you say it is a plus. this is the plus direction here, and here this is the minus direction. What does this mean? When you measure from here to here, it is 90. From here to somewhere around here should be 45. From here to here should be 135. That is 135. And from here to here should be 180. So when you have 135, you can also do the same thing from this direction to this point. You know, here it would not be 135. Instead, it's going to be 225. But that 225 is not the same thing as 135. So you're going to have it as minus 225 degree. So when you are counting from this point, it is plus, and when you are counting from this point, it is minus. And another thing is that this is the plus x axis, and to look for x components, you know, we use cos theta, and to look for y components, we use sin theta. So when you look for the cos of anything that fall between these points, use this, it would be positive. This will be positive, and this will also be positive. But when you look at the cos of anything that fall in this point, you know, this is the negative x direction. When you look at the cos of anything that fall in this side, it will be negative, negative. The same thing applied to sin theta. This part, when you look for the sign of anything that fall in this part, is going to be positive, positive. That is, this is for cos, and this is for sine. When you look at the sign of anything that fall, is going to be negative, negative. So practice those questions, they will help you a lot, and thanks for watching.